This is Unit 10, Physical Security for UCLA Extension 41771AA. The last unit in this class, we're dealing with site, building, and physical security protection measures. From a general point of view, this isn't just specifically dealing with securing data centers and information systems assets, but also securing the other valuables of a site. This topic is very important as part of the CISSP Common Body of Knowledge. Oftentimes I've heard that folks taking that exam get tripped up by physical security questions. So this is something that you really should study thoroughly if you're planning on taking the CISSP. The topics we'll be dealing with include site and facility design criteria, designing sites for proper security, location threats, perimeter security, securing the outlying boundary of your property or site, securing the interior, the buildings and the inside security, operational areas within a building that should be secured, and then lastly, environmental controls, not really part of security, but it's part of facilities management, which is something that is included in the security section of this book. We'll be referring to the official guide to the CISSP Common Body of Knowledge by Tipton, page 579 to 666. That's what covers the topics here in this class. Now, site and facility design criteria. A security survey or a vulnerability assessment is pretty similar in intent to what you'd call a security assessment in the information technology area. You look at threats, you look at your target, you look at the characteristics of your facilities, look at the controls of potential vulnerabilities. It can either involve one or both an analysis of architectural drawings, an abstract look at how the facility is designed, or an actual walkthrough of the site itself. Assuming the site has been built and is in use, you can look at the actual implementation of security controls. On-site security assessment types can range from a building inspection, a security survey of the entire site, or a very thorough security analysis, including risk analysis, looking at crime patterns in the adjacent neighborhood as part of your threat analysis, and so on. It can be as simple as just inspecting a building, seeing if the locks are secure, looking at windows and entryways and so forth, or it can involve looking at the entire threat environment and reviewing quantitative knowledge of activity in a neighborhood. And this stuff is dealt with on page 584 to 587. Following that, site planning. Site planning for security, as with information security, involves a trade-off of convenience and security. Consider roadways and vehicle design, traffic design. Mentioned in the book is, there's ways of aligning roadways in the interior of a property, such as to make it harder for someone to use a vehicle as a battering ram, such as to make vehicle traffic easier to control and more visible. Now, another topic is crime prevention through environmental design. This is an entire design philosophy looking at the human traffic and the human design and use of a facility in ways that are believed to prevent crime. It's a holistic approach. It includes landscaping and environmental design. It attempts to combine security with aesthetics. A key concept here is defensible spaces. You encourage folks who have legitimate business to gather informally in areas, and having a concentration of folks who legitimately belong in an area makes criminals and intruders much more visible, much less comfortable, and much more likely to be detected. It involves a physical design of public space. You have the concept of natural surveillance, that rather than having to hire security guards to case the site and to notice things, you rely on the eyes and ears of the legitimate site users to provide you with security. You define spaces so those who belong are present and watching, and those who don't belong are conspicuous. You focus on controllable space, making a distinction between private and public space obvious, an obvious line of demarcation between what's outside of the site and what's inside, as well as a demarcation between the various interior sites, the sites that are somewhat public, perhaps a cafe or cafeteria, versus the private sites, the offices, and other facilities. The whole crime prevention through environmental design philosophy is sometimes viewed with a certain amount of skepticism by folks in the security industry. It's a philosophy, but it's not one that has universal enthusiastic acceptance. There are folks who are somewhat critical of it or maybe believe that it is overstating its benefits. The components of it are territorial defense in terms of prevention of property crimes, personal defense, preventing violent crimes, law enforcement strategy, and mobilizing the investor and community confidence in the particular space, as referring to this as a strategy for revitalizing neighborhoods and neighborhood areas. Now, threats to a location. We went through security threats, and now we're dealing with physical security threats. And again, we have natural threats. Depending on what part of the world you are in, you can have problems with hurricanes, tropical storms, tornadoes, blizzards, earthquakes. You can have floods and other water damage. And then I mentioned in quotes, critters. People don't realize this, but living creatures, raccoons, rats, and so forth, if they have a way of getting into a facility, may do so and may cause a lot of problems. There's nothing like a network outage caused by a rat that chewed through one of your backbone cables that managed to get into a small space in the building. So a part of security is defending against living creatures that can cause issues with infrastructure. Man-made location threats are primarily fire, though fire can also be of natural origin. You can also have threats in terms of either the failure of public utilities, electrical failure, telecommunication failure, failure of gas, water, etc. There's also a threat from utilities. Electricity can be very dangerous if misused. Oil leakage, gas explosion are other areas where a utility that's very necessary for managing and running your site may become a threat itself. The recommendations are, fuel tanks should be about 100 feet from buildings. Utility systems should be about 50 feet from loading docks, entrances, etc. Utilities are often referred to as critical infrastructure, gas, electric, and drinkable water. You see a lot about protection of critical infrastructure, particularly in the post 9/11 concern with terrorism. What they're referring to are these utilities. Perimeter security. Defense in depth, that involves layers of security with the innermost layer providing the most protection. We've seen defense in depth in the information systems arena as a philosophy. In terms of perimeter security, it is literally defense in depth. It is a literal physical outer perimeter and inner perimeter. These are not metaphorical or logical concepts. These are very real. So the philosophy is you want to require an attacker to defeat multiple defensive mechanisms, ideally multiple independent mechanisms, in order for them to get to their target. This will slow down attackers. This will deter attackers. It will delay them, giving time for detection, and also allow response on the part of security personnel. If an attacker has to get through multiple levels of fencing, gates, locks, doors, and alarm systems, then the chances of them being successful in carrying out the intent of their attack and getting away with it without a detection are much diminished. Gates and fences are an important part of perimeter security, as are perimeter intrusion detection. Lighting is important. We'll get into that later, as with access control. CCTV stands for closed circuit television. It's the TV monitors that allow guards and human beings to monitor the exits and entrances and monitor the perimeters remotely. It also provides a record of activity around the perimeter for later investigative purposes. Guards, the human beings that operate this, and in design requirements for perimeter security. Now, gates and fences, some of the philosophies of gates and fences are, first you want to channel people to authorized points in order to allow identification and authentication and access control at these points. Look at the gating and queuing system for human beings at any large amusement park. It's basically channeling people to where they're supposed to go, ensuring that the process of identifying them, making sure that the folks are getting to where they need to and have the proper tickets and so forth to get there are easily handled and managed. Consider, if you go to a show or a large sporting event, what you have to go through to get into the arena or venue in terms of security, as well as checking tickets, and in terms of assistance in getting to your own seat. So gates and fences facilitate the managing of human traffic, ensuring that folks pass through identification and authentication points and that they're guided towards the location that they need to get to. Vehicle traffic is also controlled by gates and fences. That thing that you see when you go into a parking garage that lifts when you push the button to get your ticket or when you put your parking badge into the machine, that's referred to as a crash beam. It's usually, a piece of plastic. It's not terribly durable. It's feasible for folks to drive through it, though driving through it may set off an alarm or cause some notice. It's intended more to control vehicle traffic than to deter somebody who is intent on crashing a gate and doing harm. But it still serves a very valuable purpose as far as controlling vehicle traffic. Somewhat more secure are a sliding gate plus a crash beam. The sliding gate can, in fact, deter vehicles from crashing into a facility. In some apartment buildings and some parking garages after hours, you may see a particular sliding gate arrangement. And then you've got vehicle blocking systems that prevent vehicles from entering a particular space unless they have the authorization to do so, unless it's been prearranged with the facility to remove the blocking system in the first place. Gates and fences, you also need to concern yourself with utility openings. You don't want to fence the perimeter and then allow someone to get through, say, the sewer system, or someone to climb through a crawl space or a large ventilation tube to get to an unauthorized location. You need to make sure that those are secured as well as part of your access control. And this is where the critters as a source of threat is a big deal, because certain types of animals really love going through these openings and entering your facilities. Make sure there are clear zones around perimeters as well in order to make visible anybody attempting to break or crash through a perimeter. Gates and fences, and notice that when we say fences, we're also referring to walls, as walls can serve similar functions as fences, acting as a barrier. Though keep in mind that walls obstruct visibility, which is a disadvantage compared to a chain link fence. You can't see through a cinder block wall. You can see through a chain link fence. If somebody's on the outside of a chain link fence checking it out, trying to find a weak link in it, you can observe that, whereas with a wall you need to have some surveillance camera or a guard positioned outside the wall to watch that. Fencing material, you've got, of course, a trade-off of cost versus risk. More expensive, providing better protection; less expensive, providing less protection. Your standard chain link fence is usually the most cost-effective here. The standard is 6 feet high with a 2-inch mesh opening. I believe, or I've heard rumors that on the CISSP exam they do ask questions about matters like this, so if you plan on taking the CISSP exam, you may want to memorize some of this trivia. Now, barbed wire. Barbed wire is a deterrent to individuals attempting to scale a fence, makes it a bit more difficult, and also provides a visual indication that you are really not allowed to scale the fence. If it's used, ensure that it points at a 45-degree angle outwards, not inwards outwards. You want to make it difficult for somebody to get in, not somebody to get out. Concertina or razor wire is also used instead. What we see here in this picture here is an example of barbed wire up close, and in here is an example of razor wire, and I believe that the distinction between concertina wire and razor wire is concertina refers to the fact that the wiring is rolled up and can be stretched out in rolls. It got that name during the First World War, which was the first major war where barbed wire met major use. Whereas razor wire is an entirely different construction. Whereas you've got these sharp points in barbed wire, in razor wire you've got sharp edges all throughout, which tend to grab on clothing and dig into flesh and are a much more effective deterrent. Barbed wire you can sort of jump over. Razor wire is harder to get over without some major damage. If we're dealing with walls instead of fences, the standard there is walls should be about 7 feet high with 3 to 4 strands of barbed wire on the top of them. Now, something that's not in the book, but I've noticed in some other security readings that I'm sure some of you might be interested in, is guard dogs. When are dogs useful, and how do they facilitate the physical security process? Under good conditions, a dog can provide the security of 5 to 10 human security guards. They work very well in near darkness. They have a superior sense of smell and hearing. They can travel to places where humans can't go. There's very definitely a deterrent factor. If you look at this picture here, if you were faced with an animal like that and you were an intruder, that would, to me, would definitely be a deterrent. Those teeth are made for shredding flesh. They can work very well in near darkness as they depend on a sense of smell and their sense of hearing, and as well tend to see better than humans in near darkness. Some tips for handling guard dogs: there should only be one handler per dog. The dog should have one human that it reports to, that's in charge. They work best in a controlled environment without business or distraction. They don't work quite as well in environments that are busy or crowded with lots of legitimate traffic. You know, a silent perimeter at night when all is quiet is probably best. Using a guard dog in a crowded business district may not be very useful. They tend to respond to the unusual. You know, they are not extremely intelligent. If something seems out of place, they will react to it, whether that out of place is good or bad. They work effectively downwind owing to their sense of smell. And also note a distinction between the watchdog and a guard dog. The purpose of a watchdog is to provide some sort of audible warning of an intruder. Watchdogs are known for barking at the drop of a hat and can warn the human guard that there may be something going on that needs to be addressed. A guard dog serves as a more aggressive deterrent towards human intruders. A guard dog could conceivably cause some damage, pin down, knock over, or hold down a human intruder if it's trained to do so. Now, lighting, perimeter lighting, exterior lighting is very important for security. Lighting is covered on pages 603 to 605 of the textbook. In terms of planning lighting, you need to look at the type of illumination source. What is the color? What is the intensity? The pattern, is it focused or dispersed? Those have different functions depending on what you're trying to do. Height and spacing and intensity required for purpose. You require more intense light if you're, say, at a guard station where you need to check identification and need to compare the identification with of the person's face with the photograph on the ID card. Less intense lighting is required on a perimeter if you're just interested in detecting the presence of an intruder or not and don't need to worry about a positive identification. Sources of light: there's fluorescent lights, mercury vapor, sodium vapor, and quartz, each having different characteristics in terms of focus of illumination, amount of illumination, and color. Types of lighting system. A continuous lighting system is the most common security lighting system. It's a bunch of fixed lights arranged to flood an area continuously during darkness with overlapping cones. Standby lighting has a layout similar to continuous lighting. The lights are not continuously lit, but are either automatically or manually turned on when suspicious activity is detected. You know, if you have, say, a motion detector attached to a light on the outside of your house, that's an example of standby lighting. Somebody walks by, the light goes on, a few seconds later the light goes back off. Movable lighting is manually operated movable searchlights that may be lit during hours of darkness, and it's normally used to supplement continuous or standby lighting. May also be used in ad hoc arrangements where you've got a portable facility. Emergency lighting is the lighting that goes on in the event of a power outage or other sorts of infrastructure emergency. It runs off of backup power generators. It's important for security purposes, not so much for deterring intruders as it is for making sure that the legitimate users of a site can safely exit in the event of a disaster. Potential locations for lights include the perimeter, fenced and not fenced entrances. Doorways require more illumination. Structures, and then if you have critical infrastructure on your site separate from the main building, things like a small electrical substation, a transformer, gas, other sorts of utilities, you may want to ensure those are fully lit as well for security purposes. Lighting requirements typically are: you need the ability to notice an intruder at 75 feet. You can recognize there is somebody there who doesn't belong there, and the ability to recognize faces at 35 feet. Now, perimeter intrusion detection involves several different types of detection systems. These are microwave, infrared, time domain reflectometer, and video content analysis and motion path analysis. Microwave uses a controlled pattern of microwave energy into a protected area. The transmitted signal is received, and motion by an intruder or any other large object that reflects microwaves causes a change in the pattern of reception. The quantity of reception, perhaps a Doppler shift caused by motion itself. So you're using the fact that the object you're trying to detect, meaning the intruder, affects the pattern of microwaves. Microwave signals may pass through concrete and steel and must be applied with care if roadways or adjacent buildings are near the area of coverage. This is sort of similar to the police microwave speed detector, except in this case you're attempting to detect a presence of an intruder rather than the velocity. You've got two types of configurations, bistatic and monostatic. Monostatic sensors use a single sensing unit that incorporates both transmitting and receiving functions. Bistatic sensors send an invisible volumetric detection field that fills the space between transmitter and receiver, so you've got a separate transmitter and separate receiver. Monostatic microwave sensors may feature a cutoff circuit, which allows the sensor to be tuned to cover only the area within a region. This helps to reduce nuisance alarms. The fact that microwaves may extend beyond the area you're protecting means that they may respond to motion outside the area that you care about and result in false positives. Infrared sensors pick up human body heat, so it's great for detecting when someone approaches. Passive sensors detect the heat emitted by animate forms. Active infrared sensors transmit a signal via transmitter and have a reception, or it's an interruption of a beam. It's kind of like crossing the electric eye in the old style offices or services where you cross a beam of light and a little bell goes off telling them that somebody walked into the front lobby. That's the same thing with infrared here. So it can either detect the heat generated by human body temperature, or it can be used as an interruption when some large object interrupts the beam. Time domain reflectometer. This is something that if you've worked with cabling with coaxial or with Cat5 cable, you may be familiar with as a way of diagnosing cable failures. But what you're doing is you're sending radio frequency signals down a cable attached to a fence. Intruders climbing over the fence will stretch the cable or distort it even very slightly, and this causes the characteristics of the radio signal to change somewhat, and that change is detected by the alarm there. The reflected signal is it's basically based on the fact that you've got a standing wave there. You send the signal down a pathway, it reflects back on itself. If you stretch or distort the wire, the reflection changes slightly, changing the voltage and so forth at the sensing point. And in video content analysis and motion path analysis is a newer technology for using software analysis of camera images such as video content and so forth. You're programming to detect changes in the pixels that are presented to you by a digital video recorder and seeing if those changes match the suspected pattern of a potential intruder, as opposed to, say, branches being blown about by the wind in a tree, or a small animal crossing the path, etc. Software rules try to distinguish between the nature of the object there. So what we're trying to do is put some intelligence into closed-circuit TV cameras, because while computer algorithms may not be quite as intelligent as humans when it comes to detecting patterns and determining if a pattern really is a human intruder as opposed to something else, an advantage these systems have is they don't lose attention, they don't get tired. Studies have shown after 20 minutes the abilities of a guard to discern an abnormal event is severely degraded. Human beings are just not built to be at full-on attention for extended periods of time. Software, because it doesn't get tired, can do this and do this consistently. Access controls are dealt with on page 605 through, looks like 608 or so forth. There's several components to an access control system. You've got card readers. Nowadays, for the most part, when you need to get into a building, you're issued a card. That card may have a magnetic or electromagnetic device built into it. It may be a smart card with a chip on it. The card is read by a card reader. The card reader is connected to a central control system, a computer monitoring control system that logs access, who is going through what door at what time, because your card key is uniquely assigned to you, and provides for management of access via software. Important thing to note, since you guys are IT security folks, is that these computer systems can be attacked and broken into just as any other system. You may have seen a lot about concerns about hackers getting into critical infrastructure systems that control things like the electrical grid, gas, sewage systems, etc. Attackers can also get into a network and get into the computerized physical access control systems. So this is something that you need to consider in terms of classification of data and systems and classification of network facilities. As an aside, my understanding is when it comes to, say, fire alert systems, that by code in many places, those systems must be physically independent of all other control systems for purposes of safety and so forth. So that's kind of a hint that very critical systems, maybe shouldn't be attached to the same network that's used for mundane everyday activities. So you've got card readers, and it's also supplemented by locks and alarms. A lot of places, either it's not cost effective or it just doesn't provide you any value to have a sophisticated card reader system. You've got plain old ordinary keys and locks, and you've got alarms that may just alarm on an intruder, a forced entry attempt, without necessarily having a sophisticated networked back end. Several different types of cards. You can have magnetic stripe cards, similar to your debit card or credit card, with a little stripe on the back that contains encoded information in a standard format. There are so-called proximity cards, where if you're within a certain distance of the sensor, it will be able to read the card, perhaps by sending a low-frequency electromagnetic field to it and reading the response. And then there are smart cards, which contain a chip with them and certain terminals, certain contacts on the chip, metallic contacts that require insertion into a smart card reader in order to perform the access. Smart cards are very much more common in Europe as credit cards. They provide a good deal more security. A good smart card can actually contain a certain amount of cryptographic processing power, and in that sense is much more resistant to attacking and unlawful duplication than a magnetic stripe card. Closed-circuit TVs can be used for interior access control as well as for perimeter control. Their purposes can be surveillance, giving a guard or other viewer the capability to be made aware of events at multiple locations from one remote viewing area. This both saves on manpower as well as allows somebody to simultaneously view events occurring at multiple locations. You may be able to watch, say, the parking lot and see someone suspicious pull up into the parking lot, and then a few minutes later see somebody attempting entry at another entrance and be able to relate those two facts. They serve as an assessment, in terms of when an alarm notification is heard or there is some other alert received. Maybe somebody is in danger and phoned the guard station and needs assistance. You can look at the CCTV for that area and see what exactly is going on. It allows you to help assess the situation. It's a deterrent. When intruders see that you've got an effective alarm CCTV system, they may think twice about entering your property, or they may just run back to their car and put that ski mask on. It's more effective against unsophisticated intruders. It doesn't take much to fool or bypass a CCTV system, but casual sorts of intruders, it does deter a lot, and to that extent it reduces the noise level in your guard's response. You're not responding to the dumb intruders anymore, you're responding to the fewer, more sophisticated intruders. And it can also be used for evidentiary purposes if your CCTV system is set up properly, and this is where having a properly licensed installer helps a lot. You can take the records of the video and perhaps the audio and enter it in as evidence in a court of law as something that can aid in prosecuting something. It can allow you to identify and prosecute trespassers, vandals, and other intruders as well. Now, cameras, indoor and outdoor cameras are entirely different beasts. Obviously outdoor cameras need to be weather resistant and as well respond to different types of lighting position. You can have fixed position versus pan, tilt, and zoom. And then there are dome cameras, which you may see at the top of rooms in the interior of buildings. Lastly, historically, most of these cameras have been analog. You'd hook the camera up to coaxial cable, and it would in effect be a mini TV camera, and a coaxial cable would be attached to a device that would record it on tape or perhaps recordable DVD media, but it would be entirely analog from the time it sees the event at the camera itself to the time it attaches to the recorder, with an entirely separate cabling system. Now, what you've got now are IP cameras that can use your existing wired data infrastructure, can even use wireless access points, and in that way are a great cost saver, and can, because they are IP enabled, be managed and controlled via, say, a web-based interface that can be accessed by any sort of guard facility having access to the same network and having a routable connection. Needless to say, having critical security information going over your standard wired network, and in particular a wireless network, can be rather risky. There are attacker programs out there that demonstrate the risks of this. Cameras used for surveillance only take shots every so often, maybe every few seconds or so. These are not literally motion cameras with a high frame rate. Even a frame rate that is multiple frames per second, that's enough time for somebody who's in a digital network to tamper with the transmission. As a demonstration, there's a demonstration I've seen, I could probably look this up, where somebody was actually able to, by tampering with the data stream, make an object that appeared on a surveillance camera just disappear and blend in with the background. You're basically grabbing a frame as IP traffic, modifying it using an automated kind of Photoshop technique, and then inserting the modified frame back on the wire, and the endpoint camera will pick up the modified frame and take that as a legitimate one. Things to concern yourself with access control. There's lighting requirements, the light to dark ratio, the light intensity of the lightest to the darkest most surface there. You need to ensure that that actually reflects your actual requirements of the area that you're installing the cameras in. You want to make sure that that ratio matches what you're actually looking at. You've got black and white switching. Some cameras will record in color, but may also permit switching down to black and white for times when there's low illumination at night, or when there is a need for greater resolution and so forth. Black light switching is useful when you've got a camera that is full color in daylight, and at nighttime you need to have a more sensitive sensing system there. Resolution refers to the graininess of an image. The clearer your picture, the more pixels it will have. So pixels give you an idea of the resolution of the static image. Frames per second is the smoothness of the playback, the amount of resolution in the time dimension, how well you can see the motion that's occurring. And then digital images are typically compressed. Certain digital formats inherently involve compression, and other ones it has to be applied extraneously, but the standard commercial compression algorithm is the MPEG-4, and this allows you to send IP-based traffic, more images, more complex images, in less IP traffic. Recording of images, in the past, old VHS style tape recorders have been used. Currently, digital video recording is in vogue. The DVR has become the bread and butter of the CCTV system nowadays. Digital video recorders have self-contained burners for storing the data. Most security specifications require they be able to store a minimum of 45 days of camera image. The amount of storage depends on pixels, frames per second, and compression. So you need to consider your storage and archival requirements when you're looking at recording equipment as well. Displays, you can have a single image display which just shows the image the camera sees, a split screen where you see multiple camera images on one monitor, and in large format displays for showing several camera images as well. In terms of the security of the buildings themselves, as well as the interior of buildings, separating out sensitive areas from less sensitive areas or public areas from private areas. There are several different mechanisms here. Doors and locks are obviously a key component. Doors should ensure that there are proper solid construction, that the strength of the latch and frame anchor equals that of the door, and that the door itself cannot be tampered with in such a way that it can be opened when it is meant to be bolted down. Turnstiles and man traps are designed oftentimes for high traffic areas. They're designed to allow one person through at a time in order to discourage tailgating. Man traps are the closed-in areas that you will sometimes see entering certain banks or other areas that have high security, where you've got two doors. The first door lets you into the enclosed area. You then have to wait till that first door is closed before you can open the second door, which enters you into the interior or the lobby area of the bank itself. A man trap is designed so that only one person at a time can get into an area. In the case of banks, this is probably to prevent large gangs of individuals, or rather deter large gangs of individuals from suddenly storming into a bank lobby area as part of a robbery. Turnstiles are used in public arenas for public transit, subways, trains, as well as events, sporting events, large concerts, etc. They're often used to supplement guard control. Safes, keys, lock, and lock controls are important characteristics of interior building security. We'll get into those in a few more slides. Biometrics can be used as an example of something that replaces keys, replaces badge IDs, etc. Fingerprint readers, iris readers, etc. can be used as part of building security. The philosophy of this being is, one, the biometric is a bit harder to forge. Folks can't lend their biometrics to someone else. You don't typically lose a biometric as you might lose, say, a card key, a smart card, or a physical key. They can't be duplicated like a regular physical key can be. The disadvantage of them is that they are inherently imprecise, and analog biometrics can be faked. Biometrics, while they can't be lost, stolen, or borrowed in the same sense a card can be, particularly with the case of fingerprints. Fingerprints can be lifted off of surfaces and then used without the owner of the fingerprint being present. So biometrics are something that has a certain amount of promise, but you have to be aware of the limitations of it. When dealing with windows, keep in mind that there are different types of security for windows: tempered glass, wired, laminated versus bulletproof glass. You can also have glass break sensors that indicate when the glass has been shattered, setting off an alarm system. Tempered glass is similar to the glass in car windshields. It resists breakage. If you try seriously to break it, it will crumble into small pieces as a safety measure. It's often used in entrance doors and panels. Wired glass has a wire mesh embedded in it to provide resistance to blunt objects. Throwing a large brick at wired glass, hitting it with a baseball bat, will shatter the glass but not knock it out. So it makes it harder for somebody to gain illicit entrance by shattering a glass window if it's got wired glass. Laminated glass is recommended for installing in street-level windows and other access areas. It's two ordinary glass sheets bonded to a middle layer of resilient plastic. It may crack, but the pieces tend to stick to the plastic inner material. And in most strongly is bullet-resistant glass, which is typically installed in banks and high-risk areas. There are different layers of bullet-resistant glass, with the standard being 1¼ inch thick, providing protection from a 9mm round. Glass break sensors are an exterior protection barrier that can be used to deal with the fact that glass, even if you have tempered or wired or laminated glass, can still sometimes be broken. Several types of glass break sensors include acoustical sensors, listening to the sound of glass being broken or attempted to be broken. Acoustical shockwave sensors are also effective. The shockwave is the subsonic motion of the glass that's detected. A combination of acoustical and shock sensors is typically recommended as being the most secure. Finally, attached underground garage and parking structures are something that need to be considered with interior building security. There's two primary threats there: crime and people getting run over by cars. Make sure that garages are properly designed for safety purposes in terms of directing people and segregating pedestrian and vehicle traffic. High lighting levels to illuminate the exterior of it and to illuminate areas with high pedestrian traffic. So cars are less likely to inadvertently hit pedestrians, and pedestrians may feel a lot safer. And then make sure that all walkways coming from a garage that is adjacent to a building end up in the lobby or a central control area. Somebody entering a building in a garage and should end up at a place where they can be checked for identification, authenticated, and provided access to the area that they need access to. Door and lock security, page 621 in the book. Door assemblies include the door, its frame, and anchorage to the building. Perimeter doors should have hollow steel doors or steel-clad doors with steel frames. Ensure that the door and the frame itself are strong enough to resist an intrusion. It makes little sense to have an expensive, elaborate, secure lock system when the door itself can be kicked in or the frame itself crowbarred from the building. Make sure that the doors fit snugly, prevent crevices and gaps. That way preventing many simple measures of gaining illegal entry. In the old days there was a trick where somebody could use, say, a credit card and slip it in front of the door lock and work the lock open. That may still work with very cheap locks now, but the rule of that is make sure that doors close solidly. Doors that are attached to sensitive areas should automatically close, once they've been opened. A door should not be allowed to be propped open if it's a sensitive area. And, if it is, somebody does walk through the door and opens it, it should close automatically. Now, electric locks are a very secure mechanism to control a door. They actuate the door bolt rather than mechanically, it's electrically. Electric bolts have built-in position switches and request to exit hardware for safety purposes. They can be expensive, though. A special door hinge that accommodates the wiring harness and internal hardware is required. For retrofitting, electric locks usually require purchase of a new door. The strike is the area in the door frame that the lock works with, attaches to. The difference between an electric lock and electric strike is in the mechanism. In a lock door, the bolt is moved. In a strike door, the bolt in the door remains stationary and a strike is retracted. So the door bolt is stationary, the strike zips back and allows the door to be opened. In a fail-safe configuration, the strike retracts when de-energized on loss of power to allow safe exit in the event of a power outage or other emergency. Magnetic locks are popular because they can be retrofitted to existing doors as opposed to electric locks. The figure 814 on page 623 shows an example of an electric lock. Magnetic locks have a security disadvantage. They're required to have one manual device and a sensor to override the door lock signal when someone approaches the door in an exit direction. And they're basically designed to fail open in ways that other locks aren't. Anti-passback, it's where you are required to badge in and badge out. It strongly discourages sharing credentials by users. If somebody badges in, borrows my badge, that means I can't get in. If I'm already in and I allow someone to borrow my badge to badge out, that means I can't get out. The credentials are required on entry and exit. You track both the comings and goings. The other advantage of this is security knows who's actually inside the facility. In the event of an emergency, you have some idea who might be inside, who would require rescuing or other sorts of measures. Now, keys and locks. There are several different types of lock. A lock is a device that incorporates some sort of bolt or object to secure a door, drawer, or machine to be closed, open, locked, or in off position. Locks are a basic safeguard in protecting buildings, property, and are generally used to secure doors and windows. There is an Underwriter Lab standard 437 that requires that doors and locking cylinders resist attack through testing procedures including picking, impression, making an impression of a key with a material like wax or plastic, forcing test, and salt spray corrosion test for outdoor locks. You want to make sure somebody can't corrode a lock or a lock can't corrode to a point where it's useless. The door locks following these UL standards, Underwriters Lab standards, resist picking an impression for 10 minutes. This is something very interesting about physical security that folks in computer security may want to look at as an example. Is when you're talking about physical security, devices are rated in terms of the amount of time they will resist an attack. The Underwriters Lab standard is 10 minutes to resist an attack. It doesn't sound very long, but what that means is if you have that 10-minute standard, make sure an alarm goes off and someone can respond to it in 10 minutes. If your protective measure will only stand up for so long, you need a detective or reactive measure. Now, a rim lock, that's kind of an old style, latch lock. It might be the one you have on your bathroom at home. It's not strongly secure. It's usually used in combination with something else like a deadbolt to enhance security. It's more a privacy lock than a security lock. The mortise lock is much more secure because the mortise extends far into the door frame. Here we have an example of the mortise, and you can see you've got this very solid piece of metal screwed into the frame, and there's a substantial amount of depth here for which the bolt and the other lock can extend into the frame, making it resistant to forcible entry. Now, cipher locks use a numeric keypad instead of a key for access. This has the advantage of you no longer have to manage physical keys. You just manage who has knowledge of that particular number. When somebody no longer needs access, you have to change the code in the cipher lock and re-inform everyone else who has legitimate access, but that is a lot less troublesome than collecting keys and issuing new ones. It's a lot less work, a lot less expensive, and it can be done quicker. Now, safes. Safes are interior devices, fireproof or burglar-proof chests used to hold valuables. And again, Underwriters Lab rates these things based on the time required to break in. For a particular safe, given a certain set of resources, how long does it take someone to break in? If it's rated TL30, for example, 30 minutes to break in with tools. TL30 means 30 minutes to break in with a combination of tools and a blowtorch. Again, this is very interesting. They're looking at the resistance of these devices in terms of how long it will take to break in. They never advertise these things as impenetrable. Unlike the computer security field, where folks were sometimes advertise things as unbreakable, rated safes are not rated as being unbreakable. They're just rated as being it takes longer to break into. A vault is sort of like a safe. It's a walk-in safe. It's a secured room or compartment allowing human entry. And again, they are Underwriters Lab rated based on the time to enter. Containers are secured file cabinets. And these are important in areas where you handle classified documents. If you're handling documents, you may be required to lock them up in a container that meets certain standards of security, that has a certain type of lock on it. Now, with locks and keys, the administration of keys is very important. You have policies and procedures dealing with key control. You should have an individual designated as responsible for key control, somebody who manages the keys. You have policies for who gets issued and when keys are collected. You have blank keys and other keys not in active use stored securely. You issue keys only for a legitimate need, perhaps with management authorization. If it's an apartment building, you need a signed contract stating that you are a renter of a particular space in order to get a key to it, and you need to ensure that keys may only be duplicated with the permission of the key manager. Put a notice or something, say do not duplicate on the key, so somebody taking it to an ethical legal locksmith may have a hard time convincing the locksmith to make a dupe. Obviously there are locksmiths out there who don't care about this, but the issue isn't to make it impossible for somebody to illegally duplicate a key. The issue is to make it more difficult for them to do so, and to make it so that people don't casually duplicate keys just for a matter of convenience. If somebody really wants a duplicate key to do harm, or because they feel like they need it and can willingly ignore the policies, they will probably figure a way around it. But you don't want people casually duplicating keys just for their convenience, because that means you lose control of the key, and it's possible that the extra key will fall into the hands of somebody, without good intent. Interior intrusion detection, this falls into the category of defense in depth. You have your perimeter controls around the side of the property. You have your entry controls at the entrance of the business, control who can enter the lobby, who can get from the lobby to the remainder of the building. Within the building, you may partition off areas, and more sensitive areas will have their own access control and their own intrusion detection. Security may be present on the perimeter, but you also need security in the interior areas as well. Card readers can control access to specific rooms. They can be controlled through a central computer systems. This allows you a great deal of flexibility and power in terms of granting and revoking access, but again, these are computer systems. If they're on the same network as other traffic, then they are susceptible to all the other sorts of intrusions that the other devices are susceptible to as well. Now, other elements for controlling interior access include a balanced magnetic switch. It's a device that uses a magnetic field and a magnetic contact to determine if an alarm signal is initiated. A magnet's attached to the door and one's attached to the frame. When the magnetic contact is broken, the alarm switch goes off. It's basically a switch that's held open by the magnetic field that closes when that field is removed. If the door is not legitimately supposed to be open, that switch will then set off an alarm. Magnetic switches can be defeated by holding a magnet near a switch. No joke. Motion-activated cameras. Cameras with a video motion feature can be used for interior intrusion detection. And the cameras with sophisticated enough software can send an alarm signal if they detect motion of an appropriately sized object within their field. It also produces a video image, so when the alarm is produced, a security guard can view what it is that set off the alarm itself, whereas with other sensors, you'd have to either turn to an independent video camera or actually walk to the location itself. Acoustical sensors detect noise in unoccupied and presumably quiet areas, and these sensors may be enabled or disabled depending on whether somebody is in the area with authorization or not. If somebody enters an area with authorization, a sensor, of course, should be disabled. So it's a noise detection system. It acts as a detection mean for folks who enter the building legitimately, but maybe don't exit when they're supposed to. You sneak into a public area, a museum or something, hide out somewhere, and then stay past closing so you can steal some valuable objects. That's where an acoustical sensor will come in. Infrared beam sensors, you may have seen these in the Mission Impossible movies. They use an infrared beam that is projected from an emitter and detected by a sensor. If the beam is broken by some object, typically a human being, crossing the beam, it sets off the alarm. It can also notify security of individuals in hallways late at night when security is typically at a minimum. It's not so much an alarm for intruder as saying, hey, we've got a legitimate individual in a hallway when things aren't safe. Be aware that that person is there and, make sure everything's okay. Passive infrared sensors, we talked about that before, picks up the heat signature, your own body heat. So what you need to do is train a reptile to steal in an environment because they're cold-blooded. Anyway, dual technology is a combination of technology to reduce false alarms. Infrared sensors may pick up heat signatures from things that aren't human intruders. Beam sensors may be broken by things that are innocuous, that don't indicate an intruder. Acoustical sensors may detect noise from something that has nothing to do with, a human being in the area, an object, falling off a desk or something. If you use multiple technology, you tend to reduce false positives and tend to reduce wasted effort on the part of your security guards. Now, within the buildings, you will have secure operational areas. You need to think about things like your server rooms, your network equipment rooms, your distribution centers, your phone closets, etc. Not just the data center itself, but any place where you've got wiring collection, any place where you have switches, routers, hubs, other devices. Perhaps even where your wireless access points are located should be considered as an area to be secured. There's rack locks. Even within the data center itself, you may want to secure specific items. Somebody, again, defense in depth, somebody may gain entrance to the data center through devious means. If you lock devices down into the racks themselves, you're introducing a specific deterrent against theft of devices. In commercial environments where you're dealing with sensitive data, it's not unheard of for folks to break and enter and steal servers or disk arrays that contain sensitive information, ignoring other devices that have greater resale value in the market. Make sure that you lock things down. You need to secure the utilities and power as well. This is a matter both of security against intrusion as well as recoverability and prevention of interruption of the equipment functioning. Work areas should be secured as well. Ensure that your employees, people who access work areas, are aware of the policy regarding physical security and logical security of devices. Make sure that there are requirements in terms of people having to log in or sign in to get to work areas. Ensure that vendors, visitor repair people are properly escorted and supervised while they're in a work area. If you're entering sensitive computer information onto a computer screen, make sure that somebody outside of your work area can't look through a window or otherwise observe what you're typing in. It's possible to observe people typing passwords by looking at their keyboard, and that actually has been done. Other things about work areas is ensure that paper that includes sensitive information is properly shredded, at least a cost-cut shredder, or is picked up by a secure bonded shredding facility. Dumpster diving is a favorite hobby of folks who like to gather sensitive information for malicious purposes, and it's not a very good thing to send all of your output from your computer systems to a large trash bin that may not be secured or may not be watched properly. Equipment protection, you want to protect the security equipment itself from tampering. You want to make sure that the alarm system, the lines, the wires, the power supplies for the alarm system, for the lock system, for the management of the intrusion system, for the video systems are themselves secure. You don't want somebody to be able to tamper with the wiring, pull a wire, power off a surveillance camera, and then blind you effectively to what they're doing. You need to have some sort of alarm if a cable that is security critical is cut or no longer operative. If the coaxial, the old analog coax going to your old school CCTV is broken, you need to know that it's broken right away because that's an emergency situation. If you're using IP-based equipment, ensure that communications are secured and they're properly encrypted. And this is something where security professionals can add value to physical security professionals because folks who deal with facility security may not be as aware of the requirements for strong encryption as people who deal with information security. And then lastly, and this is really a big deal, if you don't know where it is, you can't protect it from theft. You need to have good inventory, good asset management. You need to make sure that your equipment is tagged, that you keep records of serial numbers, that folks follow very strictly procedures for receiving equipment, installing equipment, entering it into your asset management system, entering it into your inventory system, and that you do periodic audits to ensure that what's in your inventory system matches reality. People should not remove devices, replace devices, or switch them out without having that operation authorized by management and without having that fact recorded. Now, apart from physical theft, a lot of the stuff that physical security folks deal with is also just protection against hazards to property, hazards to life that don't involve human attackers, that don't involve theft and criminal activities, that involve things like fire, earthquakes, power outages, ensuring that the environmental control systems are working properly, ensuring that water is working, ensuring that critical equipment receives the proper power and that the power backups are functioning properly. Fire protection involves detection devices, alarms, smoke detectors, heat detectors, sprinkler systems. In data centers, you have gas suppression systems. In the old days, a gas called halon was used. Halon has been banned as being bad for the ozone layer, but there are substitutes for halon. Electrical power includes both the uninterruptible power systems that allow critical devices to run for a few minutes to a few hours on a battery backup. UPSs are designed to smooth over transient power outages of a few minutes. Entire buildings should have generator-based backups that kick in for a power outage of more than a few minutes or so. And you need to ensure that the generators are regularly tested and effective, that they start an operation when they're supposed to, and that you've got plenty of good diesel fuel for them. You don't want to have a major catastrophic power outage and realize either your fuel has all evaporated, or it's got water condensation in it, you can't start the generator, or that the generator itself has kind of corroded out and doesn't work. Now, fire prevention includes a certain number of devices here. You've got smoke detectors, photoelectric devices. It's a beam of light where the light is interrupted based on the obscuring nature of smoke. You've also got ionization detectors that rely on radioactive energy to detect smoke as well. These detect smoke, not so much fire, but it's important for human safety to protect smoke because most deaths caused by smoke inhalation. You don't actually fry to a crisp in a fire. You end up suffocating or inhaling noxious gases from the smoke, and that causes most fatalities in the event of a building fire. Fire detectors include flame detectors, both for the infrared, the heat nature of fire, as well as ultraviolet rays, which are emitted by certain types of fire. These are factors that distinguish fire from natural light and from, artificial lights that light up most work areas. You also have heat detectors, and heat detectors can work either by detection of a heat over a threshold. If the temperature goes over a certain amount, there's an assumption that there's a fire. They can also detect based on a rate of increase. If the temperature is increasing very rapidly, even if it hasn't reached a threshold, then you can assume that there is a fire going on. Suppression of fires are sprinkler systems. Wet systems have water in them all the time. Once they're activated, they'll keep spraying water. They will not shut off until someone shuts off the water source. Dry systems don't have water in them. They're not truly dry, but they won't release until the electric valve is stimulated by excess heat. Pre-action systems incorporate a detection system, which can eliminate concerns of water damage due to false activation. Water is held back until detectors in the area are activated. And in deluge systems, except all sprinkler heads are in the open position. Water works well for areas like, warehouses containing dry goods, but it is completely inappropriate for computer equipments. A water spray can completely damage equipment more than heat or smoke, particularly equipment that's powered up. Gas suppression systems are preferred in data centers for this reason. Halon was the original choice, but there are several other alternatives that are in current use. There's one chemical called AeroK, which is an aerosol of microscopic potassium compounds, and another one, FM200, is a liquefied gas. So, AeroK and FM200 are the two types of systems that you'll typically run into now.